Okay, this is now the example, the second example about a premium suspended lamina. The first case we saw in the previous lesson, it was just easy. Now, this is how the question is going to be. The diagram below shows a trapezium, as you can see. Find the center of gravity of the figure from AB and BC. AB and BC. If the figure is to be suspended from A, find the angle which AB makes with the bottom. This AB makes with the bottom. Now we know what the vertical, how we get our vertical. But before that, let us just get this, digest this. To get a center of gravity, what do we need? We need the weight, and then we need the point where those weights are acting. Now, if we have this at the trapezium, they are combining a rectangle here and then a triangle. So it means we get the area of this to get the weight, and also get the area of this to get the weight. That the weight is equal to the area times weight per unit area. But because we don't know always the weight per unit area, that's why we need it to be, let that will be the weight per unit area. So it's that now I can get the area of this because I have the length and I have the width. Now, but this one is hard because for a triangle we get half BH. I don't have the base, I have the height because from here is the same as from here to here. So how do we get the base? Now I'm going to first consider this. Of course, if I have this here, I have the hypotenuse as 30 centimeters, and I have this as 24 centimeters. Of course, this is going to be also 24 centimeters. So it's that now this one is going to be my x. It's going to be square root of 30 squared minus 24 squared, and so my x there is going to be 18 centimeters. So after getting the x, now this one is going to be 18 centimeters. So now I can get now area 1, which is going to be length times width, so times 18, and so this one is giving me 24 times 18. I'm getting 432 centimeters squared. So meaning my weight 1, the weight for this now for only this is going to be, we get this times W, we get the area times the weight per unit area, which we said is W. So it's going to be 432 W. That is my weight. Then to get the area of the second A2, you know it's going to be a half times now the base, which we've got as 18 times the height, which is 24. So my A2 here is going to be 24 times 9, which is 216 centimeters squared. Now to get the weight of this, weight 2, we get this, the area, and the weight per unit. Why do we multiply by the weight per unit? Because we saw that always area, weight is related to area. They are directly proportional. So now, to get now the area, the weight of the total. To get the total weight of this is we have the weight for this, and this now, we get the weight of the total. Weight of trapezium is going to be, now we are going to get now the weight of the trapezium is going to be, we add this plus this, we add the 432W plus 216W, which is going to give us 648. Now we just our weight of the trapezium. You can just add this. This is 6, this is 4, and that is 8. It is. Now, how are you getting the center of gravity? It means that now, to get the center of gravity of where this one is going to act, you get the center of gravity for this one. So I'm going to say this one is having the center of gravity, B1 there, and this one is having the center of gravity. Let me call this one G2. So how do we get G2? It's that G1 for this triangle now, for this rectangle. We say for the rectangle, it's actually now we are getting from AB So it means that I get from AB and BC. So from here up to here in the middle. So if this is 18, it means that from here up to the middle, it's going to be 9, comma. Then from BA up to here, if this is 24, then this one is going to be 12. Then, if I get to B2, the center of gravity for the second one, now I get from BC. The question is, how am I going to get? You know now this is going to be a right angle triangle. Now, what I'm going to do, remember, if we have a right angle triangle, this is the case we always use. If I have a right angle triangle like this, how do you get a distance? If this is my center of gravity, so always from here up to here, we are always getting 2/3 of the base, and from here up to here is always a third of the base. As simple as that. Then from here up to here, always this one is going to be, from here up to here is always, this one is always a third h. Then this one is 2/3 h from here up to here. So that's how much we are going to use to get the D2. Now, from here up here, the center of gravity, of course, our center of gravity, if I'm to be so, it's going to be somewhere here, D2. So let us get the, so that every, so if this is my F2, let me put it there. So let us get the coordinate. Now, from BC, and then from BC, and then from F, let us first get the distance from here up to here. So you know that the distance from here, just from here up to here, is going to be a third of the base. So when you get the third of the base, it's going to be a third times 18, which is going to be 6 centimeters. So from here up to here, they are 6 centimeters. But if we want from BC, we add this. From here up to here, we shall get 18, then this 18 plus this 6, which will give us 24 from BC. Then we also get the length from AB. So from AB, we get from here up to here, and then we see that from here up to here, we say it's a third h. What's the height? It's 24. Divided by 3, we get 8. So this is where our weight, W, is going to act. And this is where our weight, W2, is going to act. As simple as that. So now, this is the 18, W2. That's where our weight, W2, is going to act. So we can select now our center of gravity be there, X bar, Y bar. So you know that the weight which is going to act here is the total weight, which is the 300 and then the 648. So from there, we say that our X bar, Y bar is given by, okay, from here I say our X bar, Y bar, we use the formula saying the weight I and the coordinates where that weight is acting over the sum of that weight. So we have now the first weight. Okay, if I'm to expand this is x1, y1 plus w2, x2, y2, the whole over w1 plus w2. Now this one will give me the center of gravity of that. So now, if I'm to do that, this one is going to be, if it substitute into that formula, this one is going to be, let us substitute. So my weight 1 is 4, 2, 4, 3, 2, W. Where is it acting? This weight 1 is acting here at 9, 12. 9, 12. Then plus my weight 2, which is 2, 1, 6, W, is acting. This is where it's acting from BC and AB. So it's acting at 24, 8. Then the whole over, the sum of these two, which we saw, it was 4, 8, W. that our now is common, you can able answer it out. And so our x bar, y bar from here is going to be, we get this times this then, and then we divide by that. So this one, let me pause as I calculate. Okay, so after getting and dividing, so when you get this, I'm getting 6, 9, 7, 2 over this one, 6, 4, 8, then down here, we multiply this, then plus that, we are getting 6, 9, 1, 2 over 6, 4, 8. So when you simplify that, down I'm getting 10, going to 1 decimal place, 7, then up I'm getting 14. So therefore, our center, our x bar, our center of gravity is going to be 14 centimeters, then 10.7 centimeters. This was our part A with ease. So, then part B, you want to get a center of gravity when you are suspending it. So there, you draw a diagram with ease to show how we are going to consider the suspension. This is the diagram I'm considering now. Still the trapezium. So this is our A. This is the B, C, B. Now, of course, we know from here up to here, we are going to be having 36. When you add this 18 and this 18, we get 36. So, from the all of there, up to we have 36 centimeters up there. Then, when we come up, you see up here we have 24 centimeters. So, now we see they want us to suspend it from A. Now, if we suspend it from A, we've got our center of gravity. It's here at, let me say this is going to be my center of gravity here, which is B 14, 10.7. We said if you have suspended the line, the vertical line is going to pass through the point of suspension. We are suspending it from A and through the center of gravity. So our vertical is going to be like that, passing through that and through the point of suspension. So this one is going to be our vertical. So they wanted us to get which makes with the vertical. So this is always our vertical. The vertical is going to pass through the point of suspension and then the center of gravity. So now, let me call this, and then with the line AB, so with AB. Of course, our horizontal, if you want to put the horizontal is going to be perpendicular to that. So this will be the horizontal. So now, if I call this one theta, then it means that now I need to determine this. Now, from here, because I determine this from BC and AB, so from here up to here, I have 36 centimeters. But now, from BC, from here up to here, the length I'm getting from here up to here is 14 centimeters. Because this is that is the horizontal distance from here up to here. And then, from here up, from this up to this, I have 10.7 centimeters. What does it mean? I need now to get a distance from here up to here. So from here up to here is 36. From here up to here is 14, meaning I can get from here up to here, and what that is going to be now, from here up to here, is going to be 22 centimeters up there. So meaning now, because I'm saying from here up to here is 14, because you see this is going to be the same. So now, basing on that triangle now, we use now this triangle here. This is our theta, this is 10.7, and this is going to be 22. So that our tan theta is going to be the opposite, 10.7 over the adjacent, which is 22. And from there, our theta is going to be, so I'm getting 25.94 degrees, and that is going to be the angle. This makes with, this vertical makes with the horizontal. As long as you know the point of suspension, it means that the vertical will pass through the point of suspension and then the center of gravity. If it was as simple as if it was the point of suspension, if it was B, then the vertical would have been passing here like that, as simple as that. So that's how you have that. I wish you well.